Okay, hello. Yes, I'm going to be presenting this security in agile development use case in Typeform. I'm David Salvador, but this has been co-written with Julià and Marc Peña. So yeah, first introduction. This is a more practical use case paper in terms of how we implemented some security controls in the development workflow of a company, Typeform. So yeah, I'm gonna be explaining a little bit about this. First of all, some context. Typeform, which is this company that we perform this use case, is a software as a service company that basically specializes in online forms and all of the management of the responses and building forms, etc. And from a security point of view, the most sensitive asset that we have and we handle are basically the form responses, because these forms can be used from, for example, a restaurant that asks their clients how good was the meal, but also can be used by a hospital who is asking some previous questions before going in to see the doctor or something like that. So as you can see, we have like not very sensitive information, but also we can have very, very sensitive information, which is medical records and stuff like that. So for us, we have to treat everything as the most security sensitive possible. And then a little bit about me. I'm David I'm a member of the security team. I've been working in the security field for more than 5 years now. And I joined Typeform 1.5 years ago, something like that. And I joined basically, and there was no security team. We're building the security team from scratch. So we had this big challenge, which is let's create a secure software development lifecycle. Basically apply security in all of the steps of how a software is developed from a security point of view. And this paper is a little bit explaining how this path went through, how it went. Yeah, so first of all, I'm going to explain a little bit about about the current or the software development lifecycle before adding any security into it. So basically, Typeform follows Agile methodology for development. And inside this Agile development, the methodologies, the one that is most similar to what Typeform is doing is the one that it's called DevOps Lifecycle. I'm not going to go into very much detail because that's another presentation by itself, but basically it's a way of allowing the teams, a single engineering team, they are able to code and also to cover all of the steps. So basically from coding to releasing this new software into production, that we call production is like publishing it online. Okay. And so following this methodology, Typeform organization is able to continuously deliver software every day. And this means when this paper was written, it was around 50 deploys per day on an average. But I think that now has increased to 60, something like that. So that's a lot of new code that is being deployed every day into let's say into the internet. Oops, sorry. Yeah, this is yeah. So from us delivering so much code to the internet, to publishing it online, is from a security perspective, of course, has a good thing and a bad thing. A good thing is that, for example, if we ever detect any security problem, any security issue that needs to be solved, we have all of this agile way of delivering. So we can fix it and then submit it, and it's going to be live in production super fast. But at the same time, it's a double-edged sword, because we have to take into account that there's new code being continuously published into internet. And from the security team, how do we handle all of these changes? How we can scan and analyze and see that there's no security vulnerability being published or something like that. So this is the challenge a little bit, to find this balance. So going a little bit back into my context, I came in a previous organization that I was working. We worked in a more classical development way, in which we had the classical development flow with releases. And then, so we had, before every release, we had some testing phase. And if we had any, if we found any bugs or anything, we would submit the bugs, then fix them. And when everything was ready, we would release the new software. However, this doesn't match with this new way of Typeform working. So our approach had to be different. We had to change our mindset. And instead, security team must be seen more of a facilitator, more of an engager, rather than a blocker. We cannot stop all of these deployments because we're working for an organization, and the organization monetizes all of these changes, and that's the way it works. So we cannot stop this continuous development. So a way of doing this is by using this paradigm that is now being popular nowadays, that it's called shifting security to the left, which basically means adding more security controls earlier on the development phase. So because it's way cheaper to detect and fix an issue when it's in the coding phase, rather than when the code is already online on internet, that might be much more expensive, and things can go wrong, much more wrong. So yeah, once we have this context and we have our mindset a little bit changed, we started building this secure software development lifecycle. To start building it, first we set ourselves some goals. Some of these goals are more easy to let's say, analyze or to define some metrics, and some others not so easy. So basically, the first and most obvious goal is that we achieve secure development. That means that the code that we are producing and the code that we're putting on the internet, accessible by everyone, is our products, basically, our applications are secure. Of course, this is never 100%. You can never be 100% sure that something that you've implemented is secure, because every software has bugs, and it's impossible to guarantee 100% of free bug software. But again, we try to reach this goal. Another one is to handle security issues as soon as possible, meaning that we prefer to identify some security issue in the early stage of development rather than in the late one, because as I said before, it's way cheaper. Also related, there's a minimal impact on time. We don't want to keep these 50, 60 deployments per day that we're currently achieving. We don't want this to be reduced, because at the end, as I said, a company gets the money from being always offering new features and new stuff. So we cannot stop that. And finally, historically, the security team has always had this kind of mixed feelings among other teams, because they're the team that always saying you cannot do this, or you cannot use that, or this is wrong, something like this. So we also wanted to have more of a, let's say, open door policy, or being more like people who you can ask things to us, instead of us being like the so-called software police or something like that. So having these goals in mind, we started by splitting let's say the software development life cycle into 3 phases, because to us it's easier to then add certain controls in different areas. It makes more sense. So basically, we split it into 3: into build, deploy, and run. In build, we include all of the activities that grow from defining the new feature, for example, or gathering requirements, to actually implementing this, so coding this. This would be in the build phase. Then we go to the deploy phase. In this deploy phase, we have everything that goes from testing in terms of acceptance test, end-to-end test, integration test, all of this. And we also have the part that is more like operational, the actual deployment, which is to publish this new code into our servers, which are on the internet. And then finally, this is more related, these 2 activities are more related to the DevOps way of developing, which is to operate and monitor. Operate in terms of scaling, or basically managing all the infrastructure, adding more servers or creating a new region somewhere else, all of this stuff. And then also this is followed by the part of monitoring how our infrastructure is doing. Okay, once we had all of these three steps splitted, we added security controls to every of these steps. And also we created some other what we call transversal activities, which are security related, not checks, but activities. And we'll see later which ones are those. So yeah, I'm gonna give a brief explanation about each of these activities that we added and which one are, if we've found any challenge and so on. And the first part is the build, which I said goes from the design to the implementation. We added 3 activities. The first one is the review of meaningful experiments. A meaningful experiment is something that we internally call a Typeform. It's an internal concept. Basically, it's a way that new implementations are started. So it starts by some team that, for example, wants to, let's say, add a new button to that does something magic, whatever. The way that is started is by creating this meaningful experiment that it's called. That's basically a wiki style page where the requirements are more or less gathered, and also design is already added there. But there are multiple stakeholders, multiple people who are going to be reviewers of that definition and that requirements. And one of these stakeholders, one of these reviewers, is the security team. But we also have people from infrastructure, people from architecture, even people from legal, because sometimes we're going to handle data from our customers. So we need the legal side of all of this. And these stakeholders are going to review that everything looks correct, that there's nothing wrong with it. And if there is, through this wiki style page, we get all of these interactions asking, okay, so how are you going to handle this? Or is this data going to be encrypted? Or what are you going to do when this happens? This way, we have in a single page all of these requirements, some designs, and even some questions that other people, other teams are asking. And also, one of these good ways that it's not going back to our goals to not be blockers, is that while this meaningful experiment is being defined, where it's being written and also questions are being answered, some development can start. So there is some pieces of code that are also linked there that's saying, hey, so this is gonna look a little bit like this. This way, we're not stopping the development from going on. And if and things can start moving, then it's easier to change or tweak certain things. And then if when the security team reviews this, and if they see that it's security relevant, that, for example, they're going to use some encryption or they're going to do something privacy related, we mark this as security sensitive. This is going to trigger further controls in the development lifecycle that is going to make us review further steps of the development. And this way also, we are more or less aware of the changes that are that are going on in the whole application, without also losing a lot of time. One of these controls that I said that it can be triggered is a manual code review. If, for example, they're implementing end-to-end encryption or something like that, we're going to mark this meaningful experiment as security relevant, and then all of the pull requests, all of the code that is going to be generated by on this feature is going to have to be reviewed by one of the security members. This is triggered automatically by this flow. And as a downside of this is that sometimes this might block the development flow. But again, this is us trying to find the perfect balance between reviewing things and also not stopping the development. But sometimes this development must be put a little bit on hold, because if it's security sensitive, some things need to be reviewed. This also can trigger some risk analysis And this is like the classic risk analysis where you analyze what risk this is going to generate, if you accept them, if you're not, etc. Okay, so now we move to the deploy step, the deploy phase, which basically, as I mentioned, includes all of the more like acceptance test, end-to-end test, integration test, and also the deployments. And in here, we added 3 activities that we're going to see now. One is the software composition analysis, which is basically what it's called also third-party vulnerabilities. So basically, check if the libraries that you're using in your application, public libraries, contain any type of security bug. If so, what we do to not be blockers, we automatically send a pull request with code with the fix to the repository that has this vulnerability. This way, the developer just have to accept this pull request, merge it, and then we have a fix of this instead of blocking the development. Another activity that we perform in this step is the static application security testing. This means that we analyze the code using a third-party tool that basically scans the code and looks for possible vulnerabilities. The challenge in this activity that we found is that these type of tools produce an output. You have to then validate if the issues that were found by this application are actually true positives or false positives. So what we did, because we don't have all of these available resources to scan all of our applications, what we did is to identify the most critical applications, the one that, for example, are handling responses and stuff like that. And those are the ones that we are actively scanning them. This way, we have this balance between also like being not overwhelmed by reports and stuff, because again, we are not a very big group of security engineers, so we have to just like go for the most optimal resources. Yeah, and then another activity, the last activity that we do in this phase, it's what we call secrets detection. Basically, we have this check on every repository, and for every commit that is made into the source code repository, we check that there is no credentials or hard-coded API tokens or something like that. Because sometimes the developers use this stuff on their local machine to test things, but then they forget to delete it or accidentally add it, and they submit it to the source code repository. And this can lead to leakages and further security issues. As a challenge that we found with this is that at the beginning, to create this, what we did is to create some custom rules using also a third-party tool, but we created some custom rules. And these custom rules at the beginning, they raised a lot of false positives. And we had a lot of developers came to us saying, hey, this tool is detecting that I'm uploading a secret, but it's not correct. So we had to iterate a little bit over this set of rules to finally tune them in a better way. And now we're not receiving any of those false positives. Okay. And finally, we have the run part, which is when all the code is already in production, is running on our servers. We have several activities there. The first of all is the classic platform monitoring. So basically, we're collecting all of the logs and data that is generated by our infrastructure. This can be the web application, servers, everything that is in our infrastructure that generates any type of, let's say, behavior data, we collect it. And from there, we analyze it. And with this analysis, we're able to create alarms and reports. So for example, if we start to notice a lot of traffic that is kind of suspicious, we can create an alarm that sends us an email or some Slack or something like that, telling us that something's going on there. And then our engineers, security engineers with the infrastructure engineers, they check together what's going on. Another typical security check in this phase is to have a public vulnerabilities management. And basically it's a way of continuously scanning our infrastructure, looking for vulnerabilities in things like the operating system or the HTTP server that we're using, something like that. We have continuous scans that tell us if there's something wrong. And if so, we act on it. Then we also have dynamic application security testing. The difference between the static application security testing is that this testing is done against a running application. So when we implement a new feature of an application and we already deployed it, now we run some tests against this already running application. This can be done through two ways. One is through some automated tools that we have that look for common web vulnerabilities. And also the other is, if you remember at the beginning, I mentioned about this meaningful experiments. If there's some meaningful experiment that has been tagged as security sensitive, so the development is going to be security sensitive, at the end of this cycle also we have another check, which is some member of our security team manually reviews this application, let's say on live, or already running, in order to avoid let's say malicious actors or attackers also checking this. What we do is we use feature flags. A feature flag is a way of delivering certain features of your application to only a subset of people that you choose. And what we do here is we're going to release a first version of this feature. We don't want to block all of this development, but we want to test it also on dynamically. So what we did is that this feature is only available to the security team and some engineers that are also going to test a little bit, but more on the functional side. This way, we're letting code go to production, but we're not letting it to be available to everyone else. And finally, we also run a bug bounty program. This is very common in organizations lately, and it's a way of, let's say, artificially increase the number of security engineers that you have in your team. Because basically what you're doing here is you're incentivizing people to scan your website or your application for vulnerabilities. And instead of exploiting those vulnerabilities, we offer money. So it's a way of incentivizing them to come and tell us, hey, we found this on your website that you're vulnerable, instead of actually exploiting it and stealing data from our customers, for example. The only downside of this is that sometimes this requires some manual triage from us. We need to review if what we got is actually a vulnerability, but it's worth the time and the money, because it's saving us also a lot of time of manual reviews. Okay, and finally, we are doing also what we call these transversal activities, which are like, they don't have any specific point of time that this is done. It's like continuously, and are the following ones. We run security trainings, but again, we changed a little bit how we did this, because we're an almost fully remote company. So running workshops that are very long remotely, sometimes this can be difficult, because like you have to match the time zones, and you have to maybe the developers, they need to jump to another meeting or jump to something else. So what we did is we created small, short time, but really focused training sessions that are asynchronous. That means that they are like published online, and the developer can just go there and check them every time they want. And some of them are, well, all of them are very specific in terms of, I'm gonna give you a 20-minute workshop about cross-site scripting in this very specific scenario. This way, we don't have this hour or 2 hour long that sometimes we used to do training sessions that are covering multiple web application vulnerabilities. But they're like very difficult to follow when you are like on a more remote way of working. We also like have this what we call security consultations, but it's a way of offering to the other teams like, hey, if you ever have any concern or any question about something that you're implementing that is security related, for example, I'm gonna be handling a lot of user data. I'm gonna be handling the phone number and the email. Should I encrypt this in a database? Should I put it somewhere else? What should I do? We have different channels through those developers. They can reach to us and ask all of these different questions, and then we can follow up. And usually these questions always come before creating a meaningful experiment. This way, the meaningful experiment is already taking into account security, and we don't have to make any comment or any correction on it. Also, we have every 6 months or so, we have external security assessments made by third parties, so other companies, and they basically check. It's a classic audit that they do on all of our infrastructure, applications, everything. And this is also a way of having an external point of view of how we are doing. And yeah, so also included as a security activities like a continuous refinement and creation of this security software that the security controls that we have to maintain them, and also create new features if they requested, stuff like that. So going more in so what have we achieved? So basically, we got from the last year and a half, we've gotten like three different audits, and all of them have been very successful. So of course, you can never say that your software is 100% secure, but at least we're in a position comfortable enough to say that we're in the right direction. Obviously, there's always room for improvement, but at least we have confirmation from different entities saying that what we're doing and how we're doing it is at least in the good direction and good enough. We've, on the process of building all of this secure software development lifecycle, we found out what we suspected, which is that finding this balance between not being very impactful, but also keeping things secure is really challenging in very specific times. So this is something that we need to work on and learn from it and keep iterating. And finally, related to the last goal, which was to increase popularity, we notice an increase in our security consultations and how people try to involve us in multiple projects before we are the ones who receive all of these meaningful experiments or review code. We notice that we are included in the very early steps of every new project, of every new implementation. So we think that at least we are thought of when something new has to be done. So our popularity at least has increased a little bit, or at least they know about us, which is what we wanted to achieve. And what's next? Of course, this is something that is never fully finished. It's something that you iterate over and over. And sometimes you realize that something you were doing is not exactly well, and you have to change it, or you can add more stuff there, and so on. So some things that we have in our roadmap are basically adding more of these security controls. And also another important thing is some of these controls are generating data that currently is not we're not collecting it. So maybe like start collecting it and monitor how many, let's say, yeah, start using all of this data that it's being generated now, but it's not being treated. And finally, there's this new practice or theory called security chaos engineering that it's based on chaos engineering. And the main idea is basically to test things, but in a really, let's say, hardcore way. Basically, for example, would be me try to submit some code that has a backdoor and see at which point of the development workflow we would detect this, or if we ever would detect this. So basically, it's trying to see exactly from all of these security controls that you have, do you really would you really detect everything you're expecting to? It's basically a way of really testing things hard. In chaos engineering, it's also what they do is, for example, they have a set of machines in their infrastructure, and basically they start randomly deleting them and see how the system behaves around it. Because yeah, basically testing, it's a fault test that it's really hardcore. And with this, I finished. And that's it from my side. Thank you for listening. And if you have any questions,